So again, you are going to be doing the same exact thing that we're going to do in example 2 with our groups. Please pause the video and write this problem down. Okay, so what we'll do is first make a table. Yours will be a lot neater than that. And I will just look at maybe 3 years of this population growth. The start amount at 0 years, right, when we're first looking at this problem, is 3,000. Okay, that's in the year 2007. If this is growing at a rate of 3.5%, think about how you rate 3.5 as a decimal. Okay. And if we want to see what how 3,000 increases by 3.5%, we actually need to do 3,000 times 0.035, okay, which would be 105, and then we're going to end up adding the 105 to 3,000. And then if we were to do this again, we would do 3,105 times 0.035 over and over and over again to get our exponential growth rate. Okay. To make it a little bit easier, if you want to already include your starting value, you already want to include your 3,000, you can just go ahead and multiply this by 1.035. So that includes the original number that you're starting with, and it adds 3.5% more onto it. Okay, so our change for this table is each time I'm multiplying my number by 1.035. Okay, and you're going to do that with your growth rate as well, with your increase. You'll be multiplying it by whatever your percent is. You're going to add 1 to that percent, and that's what your increase will be. This is a little bit difficult to understand, so I'll explain this to you one more time on Wednesday. Just take notes on it now, and use your calculator to finish this table. So someone can pause the video so you can do that. Okay, and now we're going to go ahead and write an equation. We're going to look at a general rule. First, I'll write down my parent function. And we always have y equals the change. Oh, sorry, b is the change. So the change each time is 1.035. That's how much it's changing each time. It's multiplied by that to the power of x. And it's always being multiplied by our now, our start value. And our start value can be found when x equals 0. So our start value is 3,000. Okay, so this is the general rule for this exponential growth function. So in a moment, you're going to also look at a similar general rule with your group. And when you go to graph this, just make sure that when you have your axes, this should be right on the line, but it's not. That's okay. That you label your axes, X, Y, and I'm going to be looking at the years. So this axis is a little bit bigger, so I can scale it and spread it out a bit more for the years. But when I go to graph the Y value, this is the number of people. I'm not going to count all the way up to 3,000 to make my graph, okay, because there were 3,000 people. I'm going to look at my values, which my values are 3,000 to about 4,000, I'm guessing. So I am going to go ahead and go up by 1,000 each time. And you, with your group, you can decide what you need to go up by each time. And then you can plot your points. Okay, I'm just going to show you a quick example of what your poster could look like. And the sub will also let you see the same exact example. I'm just going to put it in here in a second and talk you through it. Okay, so here's a quick example of a poster that you could do. What you're going to want to do with your poster is you're going to want to graph it, write your general rule or your equation, and draw a table. Okay, and follow the directions on the small half sheet handout that the sub will give you. So you're going to have the rest of the class to work on this, and you'll have about 10 minutes to finish it on Wednesday when I see you again. All right, good luck, do your best, help each other, work together, and I will see you Wednesday.